Thank you for joining us. This is sheet metal forming using 3D printed die and 3D printed tools. To introduce myself, my name is Eric Beardsley. I work with Dynamism, so we are a professional reseller of 3D printers. And today we are joining Levi Smith. He is a 3D printing specialist from Formlabs.
Terrific. Thank you, Eric. So today it's really about just kind of talking through some of the best tips and tricks associated to 3D printing and metal forming. So I'll go ahead and get started. In terms of what we're going to learn today, maybe you guys have some expensive upfront tooling with metal forming, and you're producing those metals either by machining them or outsourcing them. And really today it's just about how to form sheet metal with some 3D printed tools in-house and how easy that could potentially do based on the application you have. Overall, we really want to kind of show you how to reduce your tooling costs if this is a high priority or high need, and then how easy it is to kind of iterate freely in-house and validate, if not, bring this into a small batch kind of workflow or production run. So that's really what we're going to be driving into. Again, my name is Levi Smith. I'm part of the 3D printing specialist team over here at Formlabs. And in terms of just the overall agenda, today we're going to talk a little bit about Dynamism, our relationship with them. We're going to talk a little bit about Formlabs, just a quick intro on what is a tool for sheet metal forming, and then we're going to drive into the case study, which is a blade guard. Most importantly, how we designed it, how we printed it, some tips and tricks, and we'll finish off with a Q&A. Just in terms of the agenda today here. So real quickly, we've been partnered with Dynamism for close to 4 years now. It's been a terrific relationship in terms of their expertise and just their overall approach to the 3D printing market, right? Best-in-class solutions with regards to SLA, FDM or FFF, metal printing, SLS, and just a range of materials. Again, just in terms of what they bring to the table, they have a range of application specialists who are built that have decades of experience focusing on applications and solving those application problems. And I think what Formlabs is always looking for with regards to its partnerships is someone that can extend the user experience of our brand through their customer base, but most important, understand the entire workflow that you're working with. What are those application problems, upstream, downstream, midstream with 3D printing? And usually they'll have a suite of solutions. And I think the best part about working with Dynamism with their experience, with the products they offer, is you just have to come to them with that application problem, and they'll have a holistic approach to solving that application problem with one of their solutions. So again, really excited. It's been a great relationship working with Dynamism. Just a quick intro on Formlabs. Our goal at Formlabs is to expand access to digital fabrication so anyone can make anything. And there's really two things that go into that mission statement there. First and foremost, how much ease of use can we inject into our printers? And a great line I always like to kind of start with is, 44% of our users have little to no 3D printing experience before working with Formlabs. And that includes folks that are coming from the subtractive space, moving over to SLA. It's not just folks that are doing FDM. This is the evolution for them. Again, anyone coming into Formlabs, 44% of our users have little to no 3D printing experience. So there's a lot of ease of use in what we do here. The second component is versatility. And that really comes down to just materials in general, but how much versatility can we inject into these printers? And we have over 20, I think close to 30 plus resins to choose from these days. That number just keeps ticking up. So that's really what we're about: ease of use, versatility. And in terms of our journey, we started back in 2011. Our founder, Max, was really excited about some of the technology he had to work with over at MIT. And the biggest issue to him was just access to this type of technology, specifically SLA. And that's when he got into his basement, built his first inverted SLA machine, the Form 1, put it up on Kickstarter, wanted to raise a couple $100,000, when in fact, over a 30-day period, had probably 3,000 backers, raised close to $3 million. And that's when we kind of figured out there's a tremendous space for these desktop professional machines for everybody, right? Just expanding access to this type of technology. 2014, we expanded on that with the Form 1 Plus, more ease of use, more versatility in materials. Form 2 was a real game changer for us in terms of just the range of market segments we're actually in now, whether that's dental, just some other additional really exciting market spaces that we're in. But the Form 2 came on board in 2015, put about 40,000 of these machines out in the world in about 4 years. And last year, back in 2019, really exciting. We launched our Form 3 and 3L platform with our proprietary technology, the low force stereolithography, which we'll actually touch on a little bit today. And then, of course, we launched our biocompatible platform in late 2019 as well. So about 70,000 machines, 70 million parts have been produced, really chasing a extremely wide-ranging and expanding market with regards to 3D printing. And what I really like about this graph is it kind of just runs through, the main component of 3D printing, what people are really focused on, that's cost per part. And what you have here is just over time, the range of applications you get access to as that cost per part drops. If you look back at 2009, 3D printing was tied to very expensive, large industrial machines, and had a very limited range of applications that could justify that cost, right? Prototyping in aerospace, automotive, mostly. And as the cost of those machines have gone down, the cost of materials, the ease of use has increased, the range of applications we get access to has exponentially increased. If you guys haven't had a chance on this call, definitely take a look at some of the work we're doing with New Balance. It's really exciting. From dentures to, today we're going to talk about some tooling, but just the range of applications we have access to now is exponentially different from 4 years ago to 8 years ago. It really has completely changed. So there's all types of 3D printing tooling out there, and there's all kinds of things you can do with it. Today, we're really just going to be focusing on metal forming. And really the way we kind of broke it down, there's a range of difficulties associated from easy to impossible. Just to give you a rough visual there, what we're going to be working through the case study today is somewhere between easy and hard, more kind of leaning towards hard once we get into the mechanics of making this piece. And overall, our goal today is just give you enough touch points to understand the potential and what you can potentially do within your workflow. Again, it's an enormously complicated subject. By no means are we going to cover off all bases with regards to metal forming today. Just really give you some solid perspective and some creative kind of touch points in terms of how you might approach it within your current workflows here. So just in terms of the overall workflow associated with metal forming, it's pretty long, right? The back end of this workflow, most folks are gonna, if you're currently doing this in-house, you're gonna have a good feel for the back end of the workflow. Today, we're really gonna be focusing on the design of the tool and obviously 3D printing that specific tool itself. So those are the two components of this workflow we're gonna focus on. And I think the rest is pretty straightforward, pretty explanatory, but want to give you that visual there. So just in terms of the case study, what we're going to be focusing on is the Sawzall blade guard replacement. Obviously, we could have easily bought this for $20. We want to just test this out in-house with some of our engineers and see if we could really build it in-house. And this is the part that we're actually looking for right here, this blade guard. And there's a couple of specific design challenges. So again, it's a two-piece part. We're really focusing on the top side of the part based on some of those design challenges, from formed features to bends near holes. And then of course, one of the things that was a little bit tricky at first is vertical walls. So this is what we're going to be focused on in terms of our presentation today. In terms of how we design the tool, we really want to kind of visualize how we're approaching forming this part. And there's really two operations we came up with. Obviously, bending the flanges for this specific piece, and then forming the radius in the middle there. So those are the two components. Again, what it breaks down to is 4 tools across those two operations with one universal jig or fixture that we use on both operations. So in terms of the first part, again, designing this piece, really, all we did is we built the block to build exactly where the edges need to be bent, and then built right around the radius. So one of the cool things about this is we did actually do a lot of alignment features as well, but essentially we just put our part in there, subtracted it from the block, and that's how we that's the initial starting point for the metal blank that we had in place, so the sheet metal blank. So again, we're using a lot of alignment features in CAD. Obviously, you guys can eyeball this, but the best, it's just an easy feature to add in your CAD program for this. So, and this was the final part there. So just to give you an idea what it looks like, here's a simple illustration. And what you have is the 2 tools that we built in CAD to form that final piece, or obviously bend the flanges around those tools. And what's really interesting is just thinking about some of the things we did to make sure this happened. You know, one of the things we did right off the bat is we built an alignment jig that fit both operations, so we could use it for both sets of tools. And then the second thing we kept in mind is being able to bend all sides of that part with one tool all at once. So just to give you a look at what this kind of looks like, and obviously the operation of the first operation in terms of bending the flanges there. In terms of the second port, you know, we essentially took the first tool, the initial CAD design to bend the flanges, and then we built an alternate version for the clearance with that formed feature. Just to give you an idea what that looks like, again, we just put the metal part on top. And again, in this tool, we did not need the alignment features because we already had the part bent to fit directly on that tool. So when we were designing the upper tool, we really wanted to focus on essentially two parts. And you know, we took the same build and then obviously tapered it to fit the right parts. So that's kind of what you see here, and just we want to taper it to the top of it right there. So with that said, you know, we didn't have to wait too long for some of these iterations. The main component in terms of building these tools was really just the universal jig. That took a couple of hours there, but the tools themselves, you know, we were able to iterate quite a bit in terms of this. And so, you know, we didn't have to wait too long to have these parts built. And just to give you another visual, what that kind of looks like here. So we'll walk through that, and then obviously I want to give you the actual process itself. We did use a piece of metal at the top just to give a thorough distribution of that compression, but just want to give you kind of a visual there. So in terms of design iterations, you know, we went through a series of different iterations here. We have a couple of jigs, a series of tools that we built out, including one that we'll touch on at the end here. But we were able to go through a range of different design iterations. And one of the biggest challenges we had was bends near holes, right? And so the first one we'll talk about is the one on the left. And you know, one of the things we did here was more or less just kind of a hack, but we used a couple of springs and just a piece of sheet metal to lock everything in place. Again, we wouldn't recommend this from a sheet metal forming component, but this is just one of the hacks we came up with internally at Formlabs. And just to give you a look at kind of what that looks like as we went through the process here. In terms of the second iteration, it came out a little bit better, but again, this is one of the more difficult components of forming this piece. And as you can see here, we changed up the tooling a little bit in terms of that last final piece. So this tool was roughly four different parts, but it solved a couple of concerns right off the bat. And that is, you know, when you're bending the flanges here, making sure that they were completely, you know, they stayed vertically bent. This is how we came up with the final tool that we use for getting those vertical walls. And it really allowed you to obviously go past 90 degrees, which is one of the key reasons why we built this specific tool. Again, this one took less than 4 hours, but you know, the forming operation was done by taking the final desired shape. And in this case, a continuous fillet and creating a ramp onto it, which would progressively roll the material over. So just want to give you kind of that visual there. And you know, this is one of the final results of that third generation process. And just a couple of things to keep in mind. You know, obviously one of the biggest concerns going into this was tools breaking. And this is something we knew going into it that was most likely going to be a factor. You know, we tried a range of different resins, but what we really finally found out was just we had actually a CAD issue right off the bat. That was we didn't design properly for clearance within our CAD. And so, you know, that's one of the rules we have right off the bat is just make room for extra clearance with regards to the tools that you build for that sheet metal and what gauge it's at. And just a couple of additional tips and tricks associated to this application itself. Make sure you sand the corners of some of your metal parts, right? And this is just going to help with the wear around your tools. But if you can take this action, again, it's going to leave your tools long lasting, or at least last a lot longer. You know, roughly what we saw on our side, and we didn't get to this level, but you know, roughly a small batch production run of maybe 1,000 parts with these tools that we made. Take advantage of some of the alignment features associated with CAD and 3D printing. Again, you can always visually eyeball this, but you know, it's prone to error. Definitely take advantage of some of the alignment features within CAD, and just definitely use that when you're thinking about 3D printing some of the tools and the jigs that you currently use in house. And definitely take advantage of some of the alignment and just a range of different alignment features that you can apply. But definitely take advantage of some of the alignment tools available within CAD and 3D printing. Another thing to keep in mind is just try to keep the material loaded in compression. It's much stronger that way. And obviously make the parts with 3D printing, you can actually make the parts pretty beefy just to prevent it from splitting. Add hard stops to the tools that you're building. And here's just a couple of examples. We touched on this a little bit earlier, but make sure you build your tool for clearance. And this is one of the key features, or one of the key things we kind of ran into as we were running this proof of concept, which is, you know, we were breaking tools and it really wasn't a byproduct of the tools we were building, or the process is really just not thinking about the clearance properly from the beginning. Lubrication is definitely a key factor here. So obviously in terms of the friction of those parts. And then of course, you know, verifying the tool with a thinner gauge metal before moving into, you know, the current gauge metal that you're currently using or will be using for that application. So just as some features associated here. In terms of 3D printing that tool, it's pretty straightforward. Again, we touched on kind of the design of the tool here. Really what we're going to walk through now is 3D printing that tool. And again, this is where it gets, you know, that is really the main work in terms of iteration and design. And really, you know, some of the heavier lifting is going to be on the front side here and the back side. The 3D printing part, as I touched on earlier, it's pretty straightforward. You know, if you can think it, you can absolutely create it. And with Formlabs, you're going to get a very strong solution to make that happen. So lots of easy use, lots of versatility. In terms of that workflow, it's really 4 steps in terms of 3D printing that part. You want to choose the right material. You want to optimize that part for print success in our slicing software, print the job on our printer, and then obviously the post-processing, which we'll touch on. We'll touch on these step by step. In terms of choosing the materials we chose were really part of our engineering class resins. We used a lot of our Tough 2000, which was that kind of teal color resin you saw in some of the earlier jigs or some of the earlier tools. We also use our Tough 1500, our durable, our rigid. Again, all these resins fit the need for each one of these metal forming applications. Most of the time, you know, we were using a lot of our Tough 2000 in our rigid, and that's kind of what you saw in some of those examples a little bit earlier. Second step, once you choose the right material, you want to prepare it in our slicing software known as Preform. And again, there's a lot of tools we've built into our Preform to optimize, make it very easy to orient and print a successful part, from, you know, one-click print to auto orientation, auto layout, auto support generation. There's a lot of easy to use tools within our Preform software. So once you have that CAD design, dropping it into Preform, essentially you're one click away from loading that up to the printer. We did use the Formlabs Form 3 to print each one of these tools. And again, it's very straightforward. So once you have it loaded up, you hit print, and you know, whether you're putting that job in as you go home for the day, or whether you're running a series of iterations during the day, it's really does the work for you. And it's you know, our print success is roughly 96-97%. So most of the time you're going to be walking back with a successful part. And then of course the last component is post-processing. So for any SLA process, it does require an IPA alcohol bath. That's what you see on the left there, our Form Wash, which is an automated washing system. So essentially you You print the piece, you put it right on top of the form wash, drops it right into the IPA alcohol bath. It will agitate the alcohol around that piece so it washes off all the residual SLA resin. And then it will pull up to dry. And from there, you can drop it right into our form cure. And you really want to take advantage of the form cure with regards to jigs and fixtures or any type of tooling you're looking to 3D print, because the material properties exponentially change with some of our engineering resins. And you can kind of see that right here in terms of the green state, which is prints right off the printer, to the post-cured state. The tensile and flexural properties almost double. And so you definitely want to take advantage of the curing step associated to our post-processing, because again, it's going to change the material attributes of the tools that you build. So just in conclusion, again, you can get pretty good results. It's quick and cheap. You can iterate quite a bit. It can potentially be good for small runs. Again, we felt based on the tools and some of the proofs of concept that we run, we could get roughly a small batch production run of about 1,000 parts. And it really allows you to validate and verify some of the tooling before we actually go into full production run. So you can do a lot of complicated things and make it a lot easier with 3D printing. So just a quick kind of rundown on the printer that printed these tools. Form 3, Form 3B, again, incredible part quality, terrific dimensional accuracy, which is fantastic with regards to these tools, building the right clearances, getting the right tools associated to the metal forming application that you currently have in-house. Easy support removal, so it's very easy to post-process some of the parts you build on our printers. Lots of versatility in terms of material availability, over 25 plus resins to choose from. A new feature on these machines is obviously the ability to print remotely. So if you're at home and you build these tools with whatever CAD program you're currently running, you can obviously upload those to the printer, have them print overnight, come into the office, and they'd be ready for post-processing. And again, a very modular machine, right? So it's built for uptime. There's over 20 plus sensors built into these machines. And they have, they're very much built for uptime here. And I guess with that said, I was going to pass it right back over to Eric.
Yeah, so just to touch a little bit on Dynamism again. So we are a reseller of professional 3D printing solutions. Our whole thing is that we are brand agnostic. There's a lot of different 3D printing technologies out there. There's different processes, there's different materials. And really, we're here to kind of help you navigate that in terms of your application. Maybe you have one thing in mind, maybe you have a full production facility, you need replacement parts and stuff like that. We're gonna help you kind of choose that ideal technology. And then one of those obviously is Formlabs, the Form 3. So we can go ahead and take it to the next slide.
Yeah, absolutely. And one thing I want to just, for anyone that's on the call today, there's a new program that we just built that we're really excited about that's coming out. We're actually presenting it to the public August 13th. Dynamism has all the details in terms of this webinar, but it's really our introduction to building factory solutions with a modular unit or a smaller unit of production in a desktop machine. And it really dives into some of our best users out there, right? So some of the work that we're doing with New Balance, building a custom material and ramping up a full production of a specific style of shoe with them, to some of the stuff that we're doing with Gillette and Mattel. A lot of are really some of our best customers, and how we went about building a customized solution for them with a desktop modular unit like the Form 3. So it's going to be a really exciting kind of webinar. If you guys are around, definitely attend. And so I guess going off that point, we're going to move straight into the Q&A here.
Okay. Yeah, looks like we have quite a few questions here. One of them is, so is this possible with FDM? It is. We actually did a very simple tool die for metal stamping, and we were actually able to press up to 16 gauge sheet metal using, it was a carbon fiber nylon. One thing that I will say here is that, so when you're using resins, the thing about SLA and resin printing is that the models come out isotropic. that they are going to have the same strength in all directions. When you do FDM, it is anisotropic, so you do get those weaknesses along the layer lines, as well as there's going to be a little bit more friction too with those layer lines, but yes, we have done it.
Absolutely. And I think
okay.
Sorry, go ahead. I was just going to say, the other thing to keep in mind is just dimensional accuracy with regards to what you're building. I know that tends to, I think those are the two things to keep in mind, is isotropic and dimensional accuracy. So those are just the two things to think about when you think FDM versus SLA.
Okay, and then there was a question about, is the Form 3 a traditional SLA, or is it an MSLA?
MSLA. So I've never necessarily heard of an MSLA. So it is, in terms of traditional SLA, yes, right? So the Form 3 actually, I take that back. So we have invented a new process called low force stereolithography, which really plays on the traditional SLA technology, if you will. So there's two traditional processes of SLA previous to the Form 3. You had that traditional VAT SLA process where the part isn't inverted, and that's what you see with a lot of the 3D systems range of machines, some of the object machines. The Form 2 was an inverted SLA machine, which was very, you didn't have to use as much resin. You didn't have to have a massive vat of resin to print the parts that you needed. Form 3 is, I guess, an iteration on that. And that is, we invented a process called low force stereolithography. So it takes the traditional inverted SLA process and eliminates a tremendous amount of peel force associated with building layer upon layer, and allows you to get more complex with what you build. It gives you a better surface finish. You get the same dimensional accuracy. I think the last component is you get a whole range of materials that we weren't able to build and print with in the Form 2. We're able to do that with the Form 3. And a great example of that is I think we've launched close to 12 new resins this year just based on that new LFS technology in the Form 3. I made that long-winded. I apologize.
Yeah. Okay, and so then there was a follow-up to that. They were asking if it was a masked SLA. What that means is that they use the LCD over the light source to mask kind of where the print is. And this is not a masked SLA, if I recall correctly.
Yeah, so it's not a masked SLA, and so it's not a masked SLA here.
Okay. Another question here. So in the example with the Sawzall foot that we were showing, were we using a steel die on the sides of the, hold on one second, the steel die to support the sides of the printed tools, or was it just on the top or bottom?
So the first couple of iterations were just on the top. So that steel die was there just to distribute compression throughout. Outside that, everything else was 3D printed.
Okay. And let's see, I am cruising through these. So we did have one question about why wouldn't we just cut it from a steel length? What's the advantages to using resins and or thermoplastics here? I think one answer here, and then I can hand it off to Levi, is just being able to do fast iterations without the need for machine labor. I'm not sure if you want to kind of add anything to that there, Levi.
Yeah, and I really just think it comes down to kind of, insourcing versus outsourcing, just like you touched on. There's the opportunity to iterate freely without a whole lot of upfront costs. There's a lot of opportunity to validate and verify previous stepping into a production run. That's really what we're thinking about when we think about metal forming with SLA specific 3D printed tools. I think those are just some of the main benefits there.
Okay, I think that about covers all the questions. If you guys do have any additional questions, feel free to reach out. sales@dynamism.com. We have a great set of application engineers here that can kind of work with you, answer your questions, as well as if you're kind of ready to move forward, feel free to check out dynamism.com. You can buy directly or request quotes through the website for all of our hardware and materials. And then lastly, I just wanted to thank everyone for attending today, and I wanted to thank Levi for his time and coming to kind of share more about this application.
Awesome. Well, Eric, thank you. Everyone on the call, thank you so much for the time, and have a great day.